Hi there, my name is Paul Kendi Obodo. I'm here to run you through 2018 JAMB Chemistry Past questions. Okay, we're going to be looking at the first question, question 1. The question says the periodic classification of the elements is an arrangement of the elements in the order of their A, we have atomic weight, B, we have isotopic weight, C, we have molecular weight, and D, we have atomic numbers. Okay, the first option is actually wrong. Okay, so let's see the reason why. Now, according to the explanation here, we have actually the first person that discovered or that made attempt to arrange the elements in the periodic table was Mendeleev, Dmitry Mendeleev. He did this job in the year 1869. And according to his own arrangements, he observed that the elements vary according to their relative atomic mass. And thereafter, after the discovery of electron configuration, it was discovered that elements actually vary according to their atomic number and not their relative atomic mass. So that gave rise to the modern periodic table, okay? And for that reason, the answer, or the correct answer, should be atomic number. Okay, so we'll go to the next question. Question number 2. Here we have, if 1 liter of 2.1 molarity sulfuric acid is poured into a bucket containing 10 liters of water, and the resulting solution mixed thoroughly, the resulting sulfuric acid concentration would be option A, 2.2 molarity, B, 1.1 molarity, C, 0.22 molarity, and D, 0.11 molarity. Option A is wrong, but let's see how we can actually solve the question. Now, using dilation factor, okay, formula, we can get the answer. So the formula is C1 times V1 equals to C2 times V2. Now, C1 is the initial concentration, which is the molarity, or mole per dm cube, or molecular molar concentration. While V2 is the volume, in this case it's in liters. C2 is the concentration after dilution, and V2 is the volume after dilution, okay? Now here we have C1 equals to 2.2 molarity, while V1 is equals to 1 liter. C2 is unknown, that's what we're looking for, and V2 is 10 liters. So substituting these parameters into the formula here, we have 2.1 times 1, 2.2 times 1 equals to C2, which is the new concentration, times 10. So if we make C2 the subject formula, we're going to have 2.2 times 1 divide 10. Our final answer should be 0.22 molarity. Okay? So looking at the options again, the correct answer should be C. So we'll move quickly to question 3. Given a diagram, you have to study the diagram, and the question says, in the above experiment, the litmus paper will initially, okay, so the litmus paper is over there, there's a source of heat here. The substance inside the test tube, or the boiling tube, is what? Sodium ammonium chloride. So you heat it, a gas or gases will be evolved, and to pass through this porous asbestos plug, okay, and react with damp neutral litmus paper. Okay, the options are be bleached, B, turn green, C, turn red, and D, turn blue. Option A is wrong. So let's see. That process, that setup is about sublimation. And sublimation is a process whereby some solid substances, which when heated, they sublime. In other words, changing from solid state directly towards gaseous state. Is that okay? It means that it will not pass through the liquid state. We have 3 states of matter. First, solid, second, liquid, and third is gaseous state. So these substances, they will pass through, they will just go directly rather from solid state to gaseous state without passing through the liquid state. And so the chemical in the test tube is the ammonium chloride. And when heated, it will give you ammonia and hydrogen chloride gas. Now, these 2 gases, they have to move from the source to where the ignition paper is. Which one will get there first? The one with the one with less mass, which is the lighter gas will diffuse faster, and the molar mass will help it to diffuse faster. And the molar mass of ammonia is 17 grams per mole, while that of hydrogen chloride gas is 36.5 grams per mole. So ammonia will diffuse faster. Ammonia is actually a base, okay? And so when it gets in touch with the litmus paper, it turns it blue, okay? So let's go back to our options. We have B, turn green, C, turn red, and D, turn blue. Okay, let's move ahead to the next question, which is question 4. Question 4, a correct electrochemical series can be obtained from potassium, sodium, calcium, aluminum, magnesium, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold by interchanging. It means that this arrangement is wrong. So how do you make it right? Option A, aluminum and magnesium. Option B, zinc and iron. And option C, zinc and lead. The last option is lead and hydrogen. Now, for the lead and hydrogen is wrong. Why? Let's see the correct arrangement of electrochemical series. It is arranged this way. If you discover, we have potassium, sodium, calcium, magnesium, aluminum. Magnesium comes before aluminum, okay? Then we'll have others follow in that order. Okay, let's go back to the option. So the correct option is that magnesium is supposed to come before aluminum. So this is where the interchanging of the element took place, okay? So let's move ahead to question 5. Question 5, let's see question 5. The basic postulate of kinetic theory of gases is that the molecules of a gas move in straight lines between collisions. This implies that A, collisions are perfectly elastic, B, forces of repulsion exist, C, forces of repulsion and attraction are in equilibrium, D, collisions are inelastic, okay? This option D is wrong, so let's see what the kinetic theory of gases is talking about. One, we have that the kinetic theory of gases states that the gas molecules move randomly in straight lines, colliding with one another and with the walls of the container. Okay? The second one says collision of gas molecules are perfectly what? Elastic. Okay, these two, don't end up going through the rest, but for your consumption, you can go through the rest yourself. But these two will answer our question. Okay? So let's go to the options again. Now the collision are perfectly what? Elastic. That is the correct answer. Collision are perfectly what? Elastic. While other options are wrong. Okay? We'll go to question number 6. The question says, on which of the following is the solubility of gaseous substance dependent? We have those factors that solubility depends on. One, we have nature of solvent. II, we have nature of solute. III, we have temperature. IV, we have what? Pressure. The options are here, okay? The first option that has III and also IV is wrong. Why? Now, looking at the factors affecting the solubility of gases, we have temperature, pressure, nature of solvent. Okay, these are the 3 factors that affect solubility of gases. Now, temperature, the solubility of all gases decreases in water as the temperature increases. So it's dependent on what? Temperature. Pressure, the solubility of a gas in a liquid is directly proportional to the gas pressure at a given what? Temperature. It's dependent on pressure also. So in the last one, nature of the solvent. The nature of the solvent affects how soluble a gas would be. So let's go and check the correct option. The correct option should be nature of the solvent, temperature, and pressure. That is 1, 3, and 4. Correct option is D. Thank you. Let's continue. Question number 7. Question number 7 reads, which of the following statements is correct about the periodic table? Okay, we've seen periodic table before in question 1. But these options are: elements in the same periodic have the same number of valence electrons. B, the valence electrons of the elements in the same periodic increase progressively across the period. C, elements in the same group have the same number of element shells. And D, the non-metallic properties of the elements tend to decrease across each period. Option A is wrong. Let's see why. Okay, elements in the same period, they actually have the same number of valence, electron shell or element shell. I.e., elements in period 3 have 3 shells, which are K, L, M. Okay, and so on. Elements in period 4 will have 4 shells, which are K, L, M, N, and so on and so forth. Now, the number of valence electrons of the elements in the same period increases progressively by 1 across the period from left to right. So as you're moving across the period, there's a progressive increase in the number of electrons. Okay, let's see the options. Okay, option B. Okay, option B should be the correct option because it says the valence electrons of the elements in the same period increase progressively across the period. Okay, we'll move directly to the next question, question 8. Now, question 8 says the boiling of fat and aqueous caustic soda is referred to as A, hydrolysis, B, esterification, C, acidification, and D, saponification. Option A is wrong, hydrolysis. Let's see. Now, this is a fat, okay? And the fat is called triglyceride. Reacting with either caustic soda, okay, or caustic potash, okay? Now we have, this might be representing sodium or potassium. Since the question says it's caustic soda, it's going to be sodium, okay? NaOH, so you have sodium here. Now when this reaction takes place, it's an alkaline, okay? We call it alkali hydroxide. When this reaction takes place, it's going to give you what? Glycerol and a salt. And that salt is the soap. And this process is known as what? Saponification reaction. And so, if we come here, our answer should be what? D. Our correct answer is D. The next question, question 9. Question 9 says, which of the following substances will react further with oxygen to form higher oxide? Option, we have A, carbon 4 oxide and water. B, nitrogen gas, NO and water. C, carbon 2 oxide and carbon 4 oxide. D, we have sulfur 4 oxide and nitrogen 2 oxide. Okay? The options, the first one is wrong. Let's see what higher oxides are. Higher oxides are oxides that contain what? Higher proportion of oxygen than the ordinary oxide. So we have ordinary oxides for each of the elements. For carbon, we have CO. For nitrogen, we have NO. And for sulfur, we have SO2. So let's see how these oxides will form higher oxides. And so when they react with oxygen, okay, they will form higher oxide. CO will form CO2, that carbon monoxide to carbon dioxide when it reacts with oxygen. And nitrogen 2 oxide, when it reacts with oxygen, it gives you nitrogen 4 oxide. And sulfur 4 oxide, when it reacts with oxygen, it forms sulfur 6 oxide. So let's go back to the options and see the correct answer. Okay, so here, this is the higher oxide of this. This one, there's no higher oxide, okay? This one cannot form higher oxide, water, but for sulfur 4 oxide and nitrogen 2 oxide, they can form higher oxide. Okay, so the correct option is D. Let's move on to question number 10. Question number 10 says that in the preparation of oxygen by heating potassium trioxochloride 5 in the presence of manganese 4 oxide, only moderate heat is needed because the catalyst acts by A, lowering the pressure of the reactant, B, increasing the surface area of the reaction, C, increasing the rate of the reaction, and D, lowering the energy barrier of the reaction. Option A is wrong. Let's see why. Now, what's the catalyst? The catalyst is a substance which alters the rate of reaction, but itself do not undergo any permanent change at the end of the reaction. The function of a catalyst in a reaction is actually to lower the energy barrier of a chemical reaction. Is that okay? So with this, we should be able to pick the correct answer. It's not B. Correct answer is not B. It's not C. But the correct answer is D. Another word for energy barrier is activation what? Energy.